Hello and welcome to Arithmetica and the fifth video in our presentation of proof and reasoning. In the previous video in this series we covered the topic of inductive logic. However, for the remainder of the series we will dedicate entirely to yet another form of logical inference called abduction. This video is primarily concerned with setting the scene, so to speak, by starting with a very short account of abductive inference. Later in subsequent videos we will provide a number of examples in the application of abductive inference. Abductive inference is often referred to as inference to the best explanation. It describes the process of inferring the most plausible explanation in reasoning to account for an observation or some data via the act of hypothesis building, which fits said data and, where applicable, supports the relating theories without contradiction. The word abduction was first used to describe this process of logical inference by the American philosopher and logician Charles Sanders Peirce. Peirce was something of a polymath, known for writing extensive volumes of works concerning mathematical logic, science, geology, spectroscopy, psychology, anthropology, and astronomy. Peirce was also one of the founders of pragmatism, the thesis that claims that the truth and worth in propositions that are of practical value are paramount, such that those that are not of any practical consequence must be rejected as meaningless. Abduction was largely popularised from Peirce's practical writings in logic and science, where Peirce was concerned with the scientist's role in constructing a hypothesis to account for some physical phenomenon. Despite this, abductive inference has had its fair share of criticism, primarily the accusation of its fallibility, owing to the dangers of leaping too quickly from an observed correlation between two events or phenomena, to conclude that one of the events must have caused the other. Cause and effect can be very difficult to appreciate, particularly, for example, in medical science, owing to the complexities of biochemical organisms. Moreover, given our informal description of abduction as inference to the best explanation, it certainly suggests a process of both justification and discovery. However, traditionally, these two notions have been regarded as separate entities. Justification is generally perceived as a formal logical process and as such lies in the realms of philosophy, whereas the notion of discovery, as presented here as the process of hypothesis building, carries with it the notion of creativity, and thus seems too intuitive and unsystematic to conform to the formalities of any logical structure, and instead pertaining to that of the human mind and psychology. However, the German-British philosopher Ferdinand Canning Scott Schiller argued in favour of abduction and its distinction to both deduction and induction, explaining that there is an apparent formality in the development of a scientific hypothesis, in that it is not as if we allow for any arbitrary process of conception, but rather that such a creative process must still conform to the evidence. Thus, a more dynamic logic, a logic of discovery as it were, has been claimed to exist, one less static, as we might say, than either deduction or, in some cases, inductive logic. An early supporter of the Peircean development of abductive inference was of the American philosopher of science, Norwood Russell Hanson. This is clearly evidenced by his works concerning the notion that observational and theoretical language were fundamentally linked, which led him to his conception of a logic of discovery. Such notions were proposed and formalized in what was probably his best-known works, Patterns of Discovery, published in 1958. In this publication, he argued that one's perceptions were subject to a filtering of sensory information via our own perceptions. Consequently, what we interpret through sight is not solely dependent on our senses alone. He provided many examples and case studies of what he argued employed what he called retroductive, that is, abductive logic, that were used on both physics and of other sciences. For Hanson, abduction followed from a prior process of explanation that allowed for a much improved best explanation that supported the observation. Despite the troubled development in its criticisms, there has been a gradual acceptance among those in a number of disciplines. It seems prudent, therefore, to consider some of the applications of abductive reasoning. We begin by providing a short account of abduction in law, before ending this video of our introduction of abductive inference. In the study of law and evidence gathering, the process of analysing the available evidence includes logical inference in providing a plausible explanation of both said evidence and the action of those involved. A good example of abductive inference in law is from the American jurist and expert in the study of law and evidence, John Henry Wigmore. Wigmore is well known for his construction of what are now called Wigmore charts, not too dissimilar to what logicians call argument diagrams. In Wigmore's 1913 publication, The Principal Judicial Proof, he presented his evidence charts as diagrams of a network of step-by-step arguments, where arrows are used to refer to specific inferences leading from premises which are shown to connect with other processes of logical inference. However, it is perhaps worth noting that Wigmore believed deduction and induction were the only forms of logical inference, despite many today accepting his process of inference to the best explanation within the Anglo-American legal framework of evidence law as abductive in nature, and as such largely distinct to deduction and for the most part induction. Thank you for watching this short account of abductive inference. In the next video in this series of proof in reasoning, we will continue from where we left off in exploring some of its applications, where we will cover abduction in mathematics and science. And so until next time, it's goodbye from Arithmetica!